All right, Crewton Ramone's House of Math. We're gonna bust a few myths here. Today's myths we're gonna bust basically revolve around girls sucking at mathematics, because they don't. The way we teach mathematics sucks. There's a difference. So here's a lovely young girl. I've been teaching her since she was about 4. She's 6 now. And her mom. Actually, in most households, it seems to fall to the mother to teach the children. But in this case, it's the dad that actually does most of the work. But look at these two. Perfectly. Can you tell this girl's going to grow up to be a beauty? I mean, there's pretty much no way around it. Fits the American beauty myth. And part of the American beauty myth is, well, if you're good looking, you can't be smart, right? If you're good looking, you can't be good at math. Pretty women aren't good at math. Nonsense. So here she is, literally on dad's knee. Quite literally playing. Does she look like she's having fun? They're building tens, making walls, having a good time, learning add-ins, starting off with tens. But that's not all we do. We're going to do algebra. We're going to start off and throw the algebra right in there, and the algebra is going to teach her the math. And there she is with a wall that's completed. Does she look like she's having fun? Dad's a little camera shy, so we keep Dad out of the picture. Here they are building more tens, except this time they're vertical. They're working on different motor skills and balance, and there's so much more going on. Using 2 hands is important. Now, the point of this is that genius does not solve problems, it avoids problems. Look at this. This is another girl who did not have the benefit of her father teaching her mathematics. And, of course, what's she crying over? What's she crying over? This is actual art that I took off of Tumblr. Algebra. Most failed subject out there. It should be illegal. The math shouldn't be illegal. The way we teach mathematics should be illegal. This is torture. This, and believe me, I know what this is like. Remember, I failed calculus in high school. I failed it my senior year. I know what it's like to stand at your locker and cry. I know it. I know exactly what this child is going through. Right? It's not an academic exercise for me. I absolutely, this is not some kind of thing where it's like, oh, I'm practicing empathy. I know what this is like. No cause, no reason for it. It's ridiculous. Play what's under the cup. See these problems right here? We're just trying to solve quick. Play what's under the cup. Build your add-ins. Get algebraic concepts down early. Algebraic thinking, they call it. Thinking algebraically. Some number plus 7 is 10. Not even a problem. Playing with stuff like this, not a problem at all. Right? Solving for X shouldn't be a cause for tears. Shouldn't cause high school students difficulty. Should be taken for granted and easy. There's another little girl, loves to play what's under the cup. Look at that. 15. What does 9 need to be 15? Under that cup, there's a 6. And you can look over here, we factored a 6, and we built some squares, and this little girl likes to play what's under the cup. Algebra is no problem. She asks me if she can play what's under the cup. She asks me if she can factor polynomials. We have fun and play math. Using 2 hands, working on 9s and 10s. You'll see at the end of this, I have supremely simple subtraction. Working on 9s and 10s makes subtraction supremely easy. There you can see the dad in the background. And let's talk about this for just a second. Fathers, work with your kids. Shouldn't just be the wife that works on this. Shouldn't just it's not woman's work. Raising these children is your responsibility too. And working with them in mathematics can be a fun thing. Can be a thing, memories that your daughter would cherish with her father for the rest of her life. Make eye contact with your children. Smile at them. Don't come broke your face. Just smile. Remove the no from the lesson. I'll teach you how to do it. Get a couple passwords, get some blocks, and you can start having fun with your little girls. Avoid all the problems that I'm going to talk about. Right? If you make eye contact with them, give them a loving look. Give them approving looks. Take the no out of the lesson. And I know some of you men have a difficult time telling your own babies that you love them. So just smile. Don't be harsh with them. Practice your patience. Play math. Here she is, working on 8s. Nobody said we had to build them all at once. We're just building 9s and 10s. And can you see that we don't really have to go all the way down here, but she's having fun, so let her go. Because I said, oh, you only have to build down to 5 because you know what? 5 and 4 and 4 and 5 are the same thing. But look, it makes a cool pattern. She builds it. Gets more reinforcement. It's fun. And again, emphasis on the 2 hands, using 2 hands to build. Whole brain exercise. Left brain, right brain. Both sides, both hemispheres working. And it's fun. And it gets their kinesthetic, visual, and auditory sensory perception working all at once. And here we look, does she look like she's having fun or not? And proud of herself, she just built some squares. We just built a 1 square. We figured out that's 4, that's 9, that's 16, that's 25. We skip counted them. It's a lot of counting when you're 5 and 6. You can see we just played. Well, look, we've done a little bit more. Now we've got up to a 7 square. We built a pyramid. That's kind of fun. She's proud of herself. She built that by herself. Counting 7 sevens, that's a lot of work. Skip counting 6s. 5s are easy, 5, 10, 15, 20, but 6, 12, 18, 20, well, that takes a little bit more work. And we can see that those are all square numbers, all kinds of mathematics learning goes on there. And this is where we're headed. Eventually, square roots and fooling around with radicals, no big deal. Easy. Been playing with it since she was 4. And then we get a little bit more of a concept of, oh, square root of 3, how much is that? That's about 1.7. Square root of 7, how much is that? Square root of 8, what do you mean 2 square roots of 2? Well, square root of 8 is 2 square roots of 2, and it's easy if you've been playing with it. Square root of 12, 2 square roots of 3. I've got tons of lessons on this. This is where we're going, but it starts here. Playing with blocks. Look at the concentration there. Just building 10s. So make the subtraction easy, gonna make multiplication easy, gonna make math easy. Get them started early. And now that I've got all these videos, other kids are playing around. And look at this little girl right here. This little girl is like, what, 6, 7 years old? I think she's 6. It's a different child. And look, she's factoring polynomials, following along with what we're doing on her computer, playing on the floor, playing blocks. There it is built. There it is symbols. And I think there's a drawing in there someplace too. Need all 3 of those things. But where does it start? It starts when they're little. Look, we're counting how many 2s are in 20. And the amount of motor skills and dexterity it took to build that was actually quite a bit. She was actually quite pleased with herself. And that, if you look at that, you can see that that is a exceedingly pleased little child right there. She is proud of her work. We're just going to start off 2, 4, 6, 8, 10. Oh, look, now we're starting to learn some multiplication. Now we can figure out that 4 can be factored, and 6 can certainly be factored, and even numbers are easy to factor. And we could count these by 2s, 2, 4, 6, 2, 4, 6, 8, or it could just be 2 4s, and that's the same, right? We'll learn lots of math. Always starting in the concrete, drawing, and symbols. Some of you may be familiar with this if you're familiar with Singapore, but we take it, always start in the concrete. And then this is a little diagram here. So we start in the concrete, moving into add-ins. 25 add-ins to begin with. We use that tray that you saw there. It gives you the first 25 add-ins, puts them in a situation where they cannot fail, makes it so that the only thing they can build is a 10 or a 9, or depending on what they're working on. So we have complete control of error. We start off with the first 25, and then we work to the next 45. But we're certainly not just going to do add-ins for a year. We do it all at once. As you saw, there's going to be algebra there. There's going to be problem solving there, solving for x. There's going to be fooling around, building things. There's going to be fun. Always start in the concrete, draw pictures of what we did, maybe put a few symbols in there. Just because they can't make symbols doesn't mean they can't learn math. I make the symbols, they do the math. They build the problems. They draw pictures of them. And you'll see later on that some of the pictures are terrible, but it doesn't matter. We're just having fun. And we're getting the representation down in their mind so that when we put these three things together, we get abstraction and visualization. Where does it start? It starts playing and building and having fun. Look, we're building tens. And look, we did ordination. We learned combinations for 10. We learned that 9 would fit under there, but an 11 wouldn't fit under there. So we learn all kinds of things about numbers and quote unquote number theory and what's the buzzword that's running around in Common Core and all these other different systems of teaching now is number sense. Well, you get good number sense when you play with blocks, and you can see the way the numbers relate to each other and their relationships. And we're gonna throw right in there, right when they're this little, we're gonna talk about negative numbers. And you can see there's the symbol is left off there because negative 10 plus 3 is negative 7. But that got fixed in the latest edition. But playing with numbers and negative numbers right from the get-go. I'm not going to wait till she's in 6th grade or 4th grade or whenever the hell they decided to introduce it. And compound teaching techniques where the algebra is just along for the ride. We're learning add-ins, we're learning factors, we're learning multiplication, we're learning add-ins for, there's add-ins for 14, 5x, and 9x right there. All this going on consciously and subconsciously. But the idea here is that they learn so much more all at once if you introduce the algebra right away. And look at that girl. That girl's a little older than these other two, but not by much. And we can certainly have introduced this to the younger children. You don't have to wait because we're just playing with blocks. Like I said, that one little girl asked me for algebra. 2nd graders, same thing, building tens, fooling around, playing. In that day, we did Pythagorean theorem, we played with algebra, and we solved for x all at once. Little girls having fun with math. The story is nonsense. Throughout time, we have discredited and discounted women's contributions to the world of mathematics and sciences. Hedy Lamarr, again, we have this myth, if you're beautiful, you can't be smart. If you're beautiful, you don't do math. Nonsense. This woman right here, yeah, I got a bad crush on her. And she's married and having babies with another man. Anyway, here's these little girls, and see, this is the beauty myth that they're exposed to in magazines, on TV, all the time. These little girls, right? And what are they doing? We're playing math, right? Here's a lovely tower that they built as a team. Here's a little girl. She's part Indian. Oh my goodness, there's the deck stacked against you. But that's what they get all the time. Pressure to look like this, pressure to think, right, that this is what they're supposed to grow up and be, and that if they do grow up and be like this, that they're not, they can't do math. That women that look like this don't do math. That women that look like this aren't intelligent. That women that look like this, that's all they've got is their looks and their body, and that they're being exploited. And there's that terrible drawing I was talking about. But you'll see in a second that woman right there, yeah, actually she can do math. But where does it start? It starts here, where we give them a real head start. Look, she's building sixes, having a fun time. Here's another girl, she's building numbers past 10. Those are the other 20. So there's 45 add-ins. Those are the other 20, right? 25 in the tray, 20 out. You put a block here, you put a block there. All they can build is 11. So if you don't have trays, you make no excuses. You can just use 2 red squares, or you could use a book, or you could use the tray itself, or you could use whatever. Just make it so that they can't fail. You put them in a situation where they can't fail, and make it so that it's fun and easy, and of course they're going to succeed. Right? So we have complete control of error. You expect for error and correct for it. And again, never get, you're not wrong, you're just getting more information. You can remove the no from the lesson easily. Look, she's having fun. There she is factoring. That's x plus 6 times x plus 4. So what do you have there? You have x squared, 10x, and 24. And she decided to get clever with her 24, and she made 20 and 4. Those are actually 6s if you get down to it. 5 and 1, 5 and 1, 5 and 1. Just building, having a good time. Making 10s. Gonna make a little house there. More towers. More algebra. Well, look at that girl is. That's x squared, 9x, and 20. I'm doing video tutoring. Here's that same pack of girls working as a team to build a really cool tower. These are the add-ins, and over here they just decided to go, and then I made them skip count each one of these. So they had 4 9s. They had to know that 4 9s was the same thing as 36 and 8s and so on and so forth. And then you can get more and more complex with the kind of things that they can build. That's a cube there, and you can see it's cross-hatched, and those are all 10s in there. So you build 10 and 10 and 10 over and over again. Better than a worksheet. Get your hands on it, and the add-ins for 10 are going to be second nature, no problem. You'd be amazed at how many 3rd and 4th grade classrooms I've been in, and kids can't tell me 7 plus what is 10, or 6 plus what is 10 off the top of their head. They got to think about it, or they look at their hands. Here, they'll just know it. Now, look at all the different things that are going on here. Let's see, we've got 2 3s is a 6. We can see that this compared to that. We can see that a 4 and a 1 is the same as a 5. 2 and a 4 is the same as a 6. So let's see here. 5 is 3 more than 2, and 6 is 4 more than 2. All kinds of things going on here. Just free play. She's just building, having a good time. Oh, we did some completing the square, and she's all... she was resting on her laurels. So x squared, 4x, what completes the square? 4. Do you see any symbols? Nope, we start in the concrete. If you were looking at the computer screen, there would be symbols because she'd be looking at the board that I put the problem on. And then she could draw a picture of it. That lousy little picture that you saw, you know, but it shows you that what she's going on in her head, right? That she can see what's happening there. And there, you know, where does it start? There's where it starts. Just playing blocks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They all want to be 10s, and then we can make add-ins for them. Here's a little girl. The parents actually hired me to teach her multiplication, and she found out that 9s were actually really easy. And then she made me this so that she, right? I love 9 because 9s are easy. We built 9s and we talked about how 9, 18, 27, 36, 45, 54, 63, 72, 81, 90. There it is written out. There it is playing with blocks. There are also the add-ins. Makes it fast, easy, and learning is fun. And look at her, right? It's the way we teach it. It's not the little girls. These were 2nd graders. This was a class of 2nd graders, and I just introduced the concept of function using x squared. And we played with square numbers, and look, I took the 9 out there and completed the square. Right? X squared 6x, what completes the square? 9. They saw that you just take half of whatever the x is, put it there, and that we can talk about the function of x. If I know that I have a square number, f, right? So they could see. We talked about it and built them as we went all the way to 12. Right? Actually, I think we went to 13 because there's 169 right there. Talk about parrot functions. The kids are right there with you. The teacher was shocked and amazed. What do you do? Play. Play. Here we are learning multiplication. Learning skip counting. 3, 6, 9 is being built. She built the 5s easier. Notice how the 5s got built first. These are easier, actually, in degree of difficulty than 4s and 3s because they're bigger. But 5, 10, 15, 20, 25, 30, etc. Count them as we build them. Playing music in the background. Multiplication rock or skip counting songs as we're playing. Look at this little girl. How could you possibly put a little girl like this in a situation where she feels stupid? Parents hired me because she was starting to have some trouble in school and it was affecting her self-esteem and it was affecting other areas of her life. You want to return domestic tranquility to your households, my friends. Fix the math problems. Kid hates to go to school, hates math, hates you, hates her math teacher, hates going to school. Suddenly they're good at math. Suddenly they go from F to A. I've had students that were getting 30s and 40s and now they're getting hundreds. Now the other kids go, wow, wait a minute, this kid's smart. Now they don't mind going to school so much. Now they kind of like the math, and now you'll see that the other grades will go up too. A lot of times, not all the time, but a lot of times you'll see the grades go down in math, all the grades go down. The grades go up in math, all the grades go up. But I can guarantee you that you fix the math problems and domestic tranquility will return to your household. Now I put that picture there once again. Danica's got nothing on that girl. This little girl's going to grow up and be a beauty. But so much more than that. The math. This will allow her, if she wants to do science and engineering, she could do science and engineering. But you know what? What if she wants to do art? Well, then she's going to do art because she likes art, not because she washed out engineering. Not because she didn't, not because she couldn't do math. Not because she didn't get good grades in math classes. Not because she looked at the syllabus at the university and said, what can I get out of this university without having to take much math? She can do whatever she wants. And you know what? Girls that are good at mathematics, scholarships. If you weren't aware of who that was, well, now you are. Now, what's the point of this? The point of this is that you can be beautiful and do math. This woman actually has a theory named after her, a theorem named after her, because she worked on it. And she's an actress, like Hedy Lamarr, and like others before her. Many people don't realize that she's actually smart and good at mathematics. And we are on the same page in a lot of ways. I've listened to her talk about her books and so forth, and book interviews and so on. And basically, the idea is letting little girls know that math doesn't suck, and that math can be sexy, and that math that you can be good looking and smart, and that being beautiful doesn't mean that you're dumb. Why would you put this child in a situation where their self-esteem is damaged? A beautiful little girl like this. Now, in this case, the parents decided to hire me to help the child. But you know what? Mom started fooling around the blocks, working with her younger children, and decided, I could do this myself. She has the passwords, and she works with her own kids. Father's a doctor. Also, he's busy quite often. The guy works crazy hours, but he also spends time working with his kids. I actually spent some time working with her dad, helping him with his mathematics because I don't know what he was doing, but anyway, he needed some help with calculus. But the idea being is that, you see that right there? Yeah, that's where she's headed from university, not just high school. And the math isn't going to be a problem. Where does it start? There's x squared, 5x, and 6 with a little 5-year-old girl. That's where it starts. Little second graders playing on the floor, playing math. Never knowing it's hard. They're factoring a polynomial right there, and they're trying to beat the other teams that are also trying to factor that same polynomial. Where does it start? It starts with little kids. You playing math with your daughters. Ah, this little girl. Sweetest little thing ever. Right? Her mom, same thing. Her mom and dad value the mathematics, understand the head start that math can give their children, or well, these blocks and the math and the method can give their children. So they work with their little daughter. They came to me for just a little while. And now I see pictures on the internet and Instagram and all kind of places where they play math. They homeschool. And math is never going to be a problem for this little girl either. She likes math. This little girl didn't like math so much. She was hating multiplication. Just hating the way she was taught because they got to her a little late. But then we started playing around and it turned out, math's not so bad. And we learned algebra and we learned a whole bunch of other stuff. So she was, even though she was there just for the multiplication, they were quite amazed to find that we learned multiplication and so much more. And of course, part of the problem with her multiplication was that she didn't have her add-ins down. So she didn't have add-ins, multiplication is difficult, subtraction is difficult, division, of course, is going to be difficult if you can't do the subtraction and multiplication, and you get the downward spiral. Well, we stopped that, and then we got the upward spiral, because then she also figured out that math might be fun, to the point where she started teaching her younger brother. When one teaches, two learn. How beautiful is that? Your siblings teach each other mathematics and play math together. In this case, they were playing with me in front of the computer, and in this case, also playing with me in front of the computer. But there's that same little girl playing with her little brother. One teaches, two learn. Where does it start? She was teaching her little stuffed animal. Add-ins for 10. Does she look like she's having fun? Does it look like drudgery? Or does it look like maybe this is something you want to do with your kids? Maybe. Or do you want this? Choose. All those parents had to do for their child. Play what's under the cup. Goof around with blocks. Might be too late for that little girl. Probably not too late for your kids, though. Just get out the blocks, play on the floor. Have a fun time. Again, where does it start? There's your add-ins past 10 again. Get more complicated as time goes by. Oh, here's the cross-handed technique. There is full-on brain gym going on right there. Again, that little girl. Never going to have trouble with mathematics, ever. Never going to be crying. Never going to be putting art up on Instagram where she draws herself crying. It's not going to happen. The problem has been avoided. I don't know how many times I've been told that you can't teach little kids math. And little girls that have told me that, oh, I'm a girl. So? As if that's some kind of excuse for why they can't do mathematics. You know what we'll close with this. You like gazing at stars? You like looking out the window at stars at night? You know, the unemployment rate for astrophysicists is 0. 0, there aren't enough of them. How about engineering? Female engineers. They're like unicorns. I was talking to this one black woman. She said in a room of 200 engineers at Cisco, she would be the only female electrical engineer, and for damn sure the only black female electrical engineer. If there are any other women in the room to begin with. Now, you can work until you die, or you can work at something you like until you die, and then you don't actually work. If you like stargazing, or maybe you like engineering, or maybe you like sciences, or maybe, you know what, you do the mathematics and you like art. Like I said, just because you do the mathematics doesn't mean you have to be a rocket surgeon, right? You can do whatever you want to do, in the words of Napoleon Dynamite. But you don't end up like this. Or like this. I put this picture in here because this is a student I had, and that was barely posed. She was freaked out the whole time she was there. Yeah. A little late, teenage girl, drove to my house, needed help with mathematics, and passed the test. Parents were like, throw some money at it, or you could have avoided the problem in the first place. All right, so here is this part of it, the very, very simple subtraction, supremely simple subtraction. It's a little book that teaches you how to subtract, how to teach your kids how to subtract. It's full of videos. There's a link, and you can find out more about this. But the idea is, and could just as easily have been division or amazing algebra or. But this book's finished. So anyway, Crewton Ramone's houseofmath.com. Play with your kids. Play with your daughters. Have fun.